All right, so the score distributions are up here. Part one I thought was really difficult. So, you know, I mean, this is still a pretty good score distribution considering it was literally the hardest test I could come up with. It's the hardest thing I could find. Part two went much better for most people. And overall, it's still a pretty decent score distribution, even given the fact that part one was so difficult. So I'm pretty happy. There's still a couple people that I feel like are a little bit underachieving. You'll definitely need to like pick it up because we can get all of these like over in that category, right? So I know you guys can do it. So get it up. All right. So any questions? And you got to specify whether you're talking about part one, like the no calculator part, or the calculator. Yeah.
The free response on part one.
Yeah. Okay. So this question actually historically is the lowest scoring AP free response question of all time.
So that makes all the question marks feel a bit better.
The College Board puts out statistics every year on like median score of the free response questions, and this question had a median score of 1.6 out of 9 points when the test was given, which is significantly lower than most free response questions. Most free response questions, when you look at the statistics, are between 2 and 4 points out of 9. So 1.6 is really low. All right, so let's go through it. Part A just says find the integral from 0 to 1 of x to the n dx in terms of n. So I think almost everyone got this part right. You just do the integration. This ends up being x to the n plus 1 divided by n plus 1. And then evaluate it from 0 to 1. It ends up being 1 to the n plus 1 over n plus 1 minus 0 to the n plus 1 over n plus 1, which simplifies to be 1 over n plus 1. Because 1 to any power is just 1, and this is just 0. So that's the answer. If you didn't simplify it, you left it like this, you get full credit still, of course. So that part was worth 2 points. Almost everybody got it right, I think. Part B. This is where it started to fall apart. So let me just draw a picture. We have this polynomial x to the n, and then we have the tangent line at that point, like that. And then we have, okay, so this is the point, like 1, 1. And then we just have this like vertical line, x equals 1. Okay, so this is just the vertical line, x equals 1. And for part B, they want you to find the area of this triangular region T. So there's a couple different ways to do this. One way to do it is to find the equation of this line and then figure out where it crosses the x-axis and then do a definite integral of the function from this point to 1. That's the hard way to do it. The easier way to do it is to realize it's just a triangle, you 1/2 base times height. Once you know the value of this number right here. Okay, so that's the way I'm going to show you how to do it. The definite integral way could technically work, but nobody did it successfully. Okay, so let's do this. So in order to find the equation of a line, you need a point and a slope. We have a point, just need a slope. So the slope of that line is the derivative of the curve, f prime of x, which is nx to the n minus 1. So f prime of 1 would be n times 1 to the n minus 1 power, which is just n. So the slope of the line is n, right? So the equation of the line would be y minus 1 equals n times x minus 1. Any questions so far? That's the equation of value. To figure out where it crosses the x-axis, you just have to set y equal to 0, right? So the x-intercept, we set y equal to 0. 0 minus 1 equals n times x minus 1. Now you just have to solve for x, right? If you divide by n, you get negative 1 over n equals x minus 1. And then just add 1 to both sides. So x is 1 minus 1 over n. That's this number here. This is 1 minus 1 over n. It's the x coordinate, or it's the x-intercept of that tangent line. Any questions so far? So if you're trying to find the area of T, then this length right here is really just 1 minus 1 minus n, right? So this length is 1 minus 1 minus 1 over n, rather, not 1 minus n. So this is just 1 over n. That's the length of the base of that triangle, correct? The height of the triangle is just 1. This is the right angle. So the area of T is just 1/2 base 1 over n times height, which is 1 over 2n. And that's what they wanted you to do, just verify that that's the area. So to do this the integral way is much more complicated. You have to solve this for y, and then integrate from 1 minus 1 over n to 1, that function, which is a mess because there's a lot of n's and x's there. Okay? This is definitely the best way to do this. Any questions on that? That's part B. That was worth 3 points. Okay, and the way that the points were split up, you get 1 point for just asserting that the slope of the line is L. Like if you got this far, just figured out that the slope of the line is n rather, then you get 1 point. The second point is for getting that the base of the triangle is 1 over n. And the third point is doing the actual multiplication to get 1 over 2n. Okay? Any questions on that? Now, I actually gave people a point. I think that the grading rubric that they publish is not really complete because I gave people a point if they even got this value as the x-intercept. It didn't say that in the rubric, but I think they probably would have given you a point for that, so I did. Any questions on that? Okay, then part C. C was crazy. I have like tons of work because I messed up so many times. So here's the way it works. It says, let S be the region that's like this space right there. It says, express the area of S in terms of n, and then determine the value of n that maximizes the area. So my first inclination was, let's just integrate, like take two pieces, like split it up into two pieces, and integrate from 0 to this point, S, and then integrate from this point to 1 of this little polynomial minus the line. And it was a mess. It turned into a real mess. So a better way to do it, after thinking about it for a long time, a better way to do it is to just take the area under the polynomial minus the triangle. Right? If you took the area under the polynomial minus the triangle, you get what you're looking for, right? Which is totally straightforward considering the work that you did in part A and part B. It was just those two things combined. That was it. This ends up being 1 over n plus 1 from part A. This ends up being 1 over 2n from part B. It's that simple. Like once I realized that, I'm like, oh God, I really wasted all that time. I literally wasted a half hour on this problem trying to do that. I don't know if you did too. So that's the first part of the question, express the area of S in terms of n. And then the second part is to determine the value of n that maximizes the area of S. So this is just first derivative test on this formula. So S prime is negative 1 over n plus 1 squared. plus 1 over 2n squared times 2. Is that right? Yeah. One over 2 n squared, okay. Right? So the way I got those derivatives is I just thought of that first thing as being n plus 1 to the negative 1 power. So its integral would be negative, or derivative would be negative 1, n plus 1 to the negative 2 times 1, chain rule. And then the second piece is 1/2 n to the negative 1. So its derivative would be positive 1/2 n to the negative 2, which is this, okay? And then just set it equal to 0 and solve. So I could write this as 1 over 2n squared equals 1 over n plus 1 squared. So that means that 2n squared equals n plus 1 squared. I could just square root both sides, and I get radical 2 n equals n plus 1. And I forgot to think about this a little bit. I found something on Friday, like, why can't this be plus or minus? So let's think about it now. Why can't this be plus or minus? Right? If something squared was something else squared, then why can't the square root be plus or minus the square root? Because here's what I did. Like, I didn't consider the plus or minus when I was doing this problem. I just solved. So what I got is I moved this over. So I had radical 2n minus n equals 1. So then I factored out a common factor of n, 2 minus 1. So then n is 1 over radical 2 minus 1. So I guess the question is, why can't that be plus or minus? Actually, that wouldn't be plus or minus. This would be plus or minus. So this would be like plus or minus. Why can't it be like that? Any ideas? And when I look at the actual grading rubric, the answer they give is the answer I came up with, which is 1 over radical 2 minus 1. But why can't it be the negative version of that? I haven't thought about it very deeply. I just thought about it for a second on Friday, and then I forgot about it until now. But
sure. The first quadrant, and it's negative radical 2 minus 1 and negative.
well, n is just the exponent of the polynomial. Like, this is x to the n. There's no reason why that can't be negative, is there? I don't think it can't be. Like, I'm just thinking about it. I don't think it can't be. So truthfully, I don't really know. I don't know why it can't be the plus or minus square root 2 thing here. I mean, there's no real restrictions on n. So I don't know. Well, maybe this is why it can't be negative, why n can't be negative. Because if n was negative, then this length here would be negative, and that doesn't really make any sense. So maybe that's why. That kind of makes sense, right? If you're talking about length, geometric length, it can't be negative, so that's what rules that out. I don't know, I'd have to think about it a little deeper. But anyway, that's the answer. This was a really tough problem. Yeah.
Could you number 5 on part B?
Yeah, sure. So on the calculator part, number 5, Okay, this is just an area problem. So they're giving you a graph of velocity. And the graph kind of looks like this. There's like a little region like that.
I'm still on the calculator.
So it looks like that. If you just calculate areas, just add up squares, this area ends up being 13.25. This area ends up being 7.25. And the point where it crosses right there is at 5.5. And this is 12 over here. So if you look at the questions, it says, first of all, Newton ended up 6 feet to the right of where he started. That's definitely true because you start out at the food bowl or whatever, you move 13.25 feet to the right, velocity is positive, and then you move back 7.25. If you subtract these, you end up getting 6 feet. That's definitely true. Number two, Newton traveled exactly 20 feet. That's not true. If you add up these two areas, you get 20.5. So that's not true. And choice three says Newton was farthest from his food dish at 5.5 seconds. That's definitely true because he moves 13.25 feet away and then comes back towards his food dish. So yeah, he's furthest away at 5.5. So that's it. The way I would calculate these areas is just break it up into like all of whole squares, like just add those up, and then just take each triangle and add them together. And it can be done pretty quickly just by visualizing it. All right, what else?
Can you do number 7 as well?
Yeah, on the calculator part? Sure. All right, so number 7, it says a dome over a stadium is modeled by the boundaries of the function y equals 9 minus x squared, which looks like this. Crosses through the x-axis at -3 and +3. And the x-axis, the cross-section is perpendicular to the y-axis are squares. That means that there's squares coming up out of the board like this way. Squares, right? So the first thing you should notice about this is they're talking about cross-sections perpendicular to the y-axis. So we have to use functions of y and y values as the limits of integration. Okay, that's the first thing you should notice about this problem. So if the function is y equals 9 minus x squared, if I solve for x, I get x equals plus or minus the square root of 9 minus y. Questions on that? So this half parabola right here is x equals the square root of 9 minus y. And this half parabola over here is x equals negative square root of 9 minus y. So the answer is going to be the integral from 0 to 9, because that's what these y values are, 0 to 9, of the area of a typical cross-section. I'm just going to write it as s squared, because they're squares, right? dy. So s is this length right here, which is just the difference of the top curve minus the bottom curve if you turn your head sideways. So it ends up being the integral from 0 to 9 of radical 9 minus y minus negative plus radical 9 minus y squared. You can do that on your calculator. You can simplify it a little bit first to make it easier to enter in. It ends up being 2 radical 9 minus y squared dy. You just do it on your calculator and it ends up being 162. John?
6 on part A.
Sure. So this is the non-calculator part. Number 6 is an average value. So we only need to find the average value of f of x equals e to the radical x over radical x. Integral from 1 to 9. So the answer is 1/8 width of the interval, times the integral from 1 to 9 of e to the radical x over radical x. So I picked this problem because it requires you to remember how to do u substitution. This is a u substitution problem. So u is just equal to radical x. du is 1/2 x to the negative 1/2 dx. So dx is 2 radical x du. And then the key is when you make the substitution, substitute this radical x, but don't substitute this radical x. Because if you substitute this radical x with u, then nothing's going to cancel with this radical x. So this ends up, when you substitute it in, you get e to the u over radical x times 2 radical x du. And now you can see that these just cancel. So it ends up being 2e to the u, which is 2e to the radical x from 1 to 9. So this ends up being 2e cubed minus 2e. And you multiply that by 1/8. So you end up getting e cubed minus e over 4, which is choice A.
I don't know.
Does everybody understand that? I messed up the answer key on number 7. That's why, for some of you, your score changed on Friday. Messed up the thing. What else? Yeah.
8 on this is the calculator.
Okay, number 8 on the calculator test. So they're telling you d of x equals the integral from 0 to 2x f of t dt. So if this is all you had, what type of problem is this? FTC part 2, right? So g prime of x is f of 2x times 2. Chain rule, right? Chain rule is you plug this in and then you differentiate that. So if you're trying to find g prime of 3, it's just f of 6 times 2. F of 6 is -1, just based on your picture. This is -1 times 2. The answer is -2.
I found 2x. For what reason?
You did what?
To f prime of 6. So it's, I
Uh,
don't know why. That's totally.
that's why the answer's there. All right, what else? Yeah.
Can we do, number 2 and part 1?
Sure. So you have a velocity function that looks like this, something like that. This area is 2p, this area is 2p plus q, and this area is q minus p. And the question says, what is the difference between the distance traveled and the displacement? So distance traveled is the sum of all these absolute value areas, right? So it's going to be 2p plus 2p plus q minus p, right? So this simplifies to be 3p plus 2q. Everyone agree with that? That's distance traveled. You just calculate the area of this, in absolute value, the area of that. Displacement, on the other hand, counts this area as negative. So it's this plus this minus that. So it's going to be 2p minus 2p plus q plus q minus p. So if you combine all those, the two p's just cancel, so you get negative p, and then negative q plus q, they cancel. So if you subtract them, 3p minus or plus 2q minus negative p, you get 4p plus 2q. You got to subtract negative p. You just subtract p. That's why that answer's there. Any questions on that? So displacement is the definite integral of velocity. Distance traveled is the definite integral of absolute value of velocity. That's it.
We go over, I didn't get it wrong.
On the non-calculator part?
Yeah, but I have.
Sure, yeah, okay. So this says, find the volume of the solid generated by rotating the area enclosed by 1 minus radical x. So let's try that. So 1 minus radical x is half of a parabola, bottom half of a parabola opening to the right, but up 1 unit. So it kind of goes like this. This is y equals 1 minus radical x. Y equals negative 2. That. And the y-axis about the line y equals negative 2. So you want to rotate around this line right here. So remember, the trick is to just shift the whole picture up so that the axis of rotation is just the x-axis, right? So I'm going to picture, instead of this, I'm going to picture this, where it's the same picture, but it's just up 3 units. And I'm rotating around the x-axis. It's the same area, right? If you rotate this around the line y equals negative 2, or you rotate this around the x-axis, it's the same, right? So what you need to do then is first figure out the equation of this. So the equation of this would be 1 minus radical x plus 2, because you're shifting everything up 2 units. So this is 3 minus radical x. What's the other thing you need in order to calculate this volume? Yeah, you need to figure out like the limits of integration. It's 0 to something, right? So you can do that either by setting this equal to negative 2, or you can do it by setting this equal to 0. Either way, right? So this one seems easy. So I'm just going to set this equal to 0. So radical x equals 3, and x is 9. So this is 9. The next thing you need to figure out is what does a typical cross-section look like? Like if I rotate this around the x-axis, you end up getting like a kind of like a cone-shaped thing, right? But what does a typical cross-section perpendicular to the x-axis look like? The choices are discs and washers. Definitely disc, right? There's no space between the area that I'm revolving around the x-axis and the axis of rotation itself. So it's a disk, right? So it's just going to be the integral from 0 to 9 of pi r squared dx, which is the integral from 0 to 9 of pi, and then r is just this function, u minus radical x. All right, and this is not a calculator question, so you got to do it out, which is time consuming, but that's what you have to do. So this would be pi times the integral from 0 to 9. There's really no option other than to FOIL it out. So you end up getting 9 minus 6 radical x plus x. So this is pi times 9x minus 6x to the 3 halves times 2/3. Yeah, no, that's right. Thirds. Sometimes I get confused in my head whether I'm integrating or differentiating. I'm integrating, so we add 1. Plus x squared over 2, 0 to 9. And then just evaluate it. So this is pi times, if I plug in 9, I get 81 minus 12/3 is 4. 9 to the 3 halves power is 27. So this is 4 times 27 plus 81 halves minus, and if I plug 0 in, I get 0. Are we okay with that so far? So this is pi times, I need a common denominator, it's halves. So this is 81 times 2 is 162 minus, this is 108 times 2 is 216 plus 81 halves. So 162 minus 216 plus 81, I don't know what that is. This is, well, 162 plus 81 is 243. 243 minus 216. 43 minus 16 is, okay. 40, what is it? 27? Right, 27, yeah. So it's 27 halves pi. That's the answer. Choice B. So the hard part of this problem, in my opinion, is doing the arithmetic. But you can count on them doing that to you once, at least, on the non-calculator part, just to see if you can do it. But us.
Because if it's with FFP, you know the question, there's going to be some big interval of it, and then it's technically.
Anything at all. We're good? All right. So we're totally done with the material. Tomorrow, I'll talk about like what the next 6 weeks is going to look like. But that's all we have until the AP exam, 6 weeks. So, and then we'll be totally done with everything.
So are we gonna start going over particular subjects that we flagged that we're not good at?
Well, I think that part of this, 6 weeks, should be each person, figuring out what they're not good at, because I could just sit here and review the whole course, but I think that might be a waste of time. So I think it would be better if you guys came up with what you feel are your weaknesses. So tomorrow, I'm actually going to give you a list of every topic that we've covered. So you can actually just kind of go through it and say, good with that, not good with that, good with that, good with that. You know what I mean? And then you can come with questions. Every week, we're going to have a problem set of AP questions. That's roughly half, maybe a little bit more than half of an actual AP exam. So, I mean, you can count on it taking maybe 2 hours total during the week, but I'll give you lots of time during class to complete it. So, about that. I'll answer any questions you have at any time, and then we're going to have one little practice test a week on Fridays. That's kind of the structure of the next few weeks. And then over spring break, you'll just have one practice test to do in its entirety. Sorry. But, it's 3 hours, which kind of sucks, but you'll be all right.
Well, those practice tests should be great.
Yeah, I'm going to grade them. It's like every other quarter. Don't worry too much about your grade. Everybody's grade's going to be just fine. But I think you're going to be surprised at how easy these seem, because these questions are going to be taken from one actual test. Normally I comb through all the questions I can find on a topic and I pick the hardest ones. That's not how it is on a normal test. On a normal test, if there's 45 multiple choice questions, to you guys, 35 of them are going to seem way easy, and 10 of them are going to be challenging. You know what I mean? So on these practice tests, I mean, I would not be surprised if lots of people are getting hundreds, because, you know, it's a different feel when it's all like easy questions than when they're really all hard questions, of course, you know, so.
So are they gonna be graded the same way, or?
Yeah, I'm gonna grade it the same way. But I anticipate people's grades are gonna be like exponentially increasing. I would hope. But don't worry about your grade. That, you know, is anybody dissatisfied with their grade so far this year? If you are, you should talk to me. It's negotiable. I don't care about grades. I honestly don't. All I care about is if you guys learn stuff and you do well on the AP test. That's what I care about. Okay? It's not like every grade I give out comes directly out of my paycheck. I get paid the same, whether you get A's or F's. All right, I'm gonna stop recording.
That makes sense, what I did. Okay. I don't know how I remember how to do it, but